A Cold War satellite saw the signature it was built to detect. Not a shadow, not a rumor, a double flash over the South Atlantic. If it was nuclear, someone had tested a bomb in secret. If it was not, one of the most important surveillance systems in the world had seen a ghost. That is the problem at the center of the Vela Incident. The mystery is not just what happened in the sky. It is why a system designed to make the world know when a nuclear weapon had been tested could produce a record that still did not settle the question. The Vela satellites were built for a specific kind of fear. They watched for nuclear detonations from orbit, using instruments that could register flashes of light, radiation signatures, and other signs that a test had taken place. The optical part mattered because an atmospheric nuclear explosion does not simply look like a normal burst of light. It can produce a two-stage flash. First, an intense burst. Then, after the expanding fireball changes how light escapes, a second rise. That pattern was not casual. It was the kind of signal a monitoring system was trained to care about. On September 22, 1979, one Vela satellite recorded an event in the South Atlantic region. The phrase that followed it was simple enough to become dangerous: double flash. The moment a sensor says nuclear, everything around it changes. Aircraft can be sent, ships can look, analysts can search for radiation, debris, weather patterns, acoustic traces, and anything else that might turn a signal into proof. But the South Atlantic is not a laboratory table. It is dark water, weather, distance, and silence. In the public record, the confirming evidence never became clean enough to close the case. That is where the Vela incident becomes stranger than a simple secret test story. If a bomb had gone off, why was the supporting evidence so hard to make public and decisive? If no bomb had gone off, why did the original signal look serious enough to keep the argument alive? The event sits in that gap, not proof enough for closure, not weak enough to forget. This is the part most mystery versions skip. A satellite record is not a verdict. It is a trigger. It starts a chain of searches, arguments, and exclusions. It asks other systems to answer the same question from another angle. Do the winds make sense? Do the instruments agree? Does the ocean carry sound the way a blast should? Does anything radioactive appear where it should not? The Vela event survived because those follow-up questions never produced a public answer clean enough to make the first signal disappear. Declassified records do not give one neat answer. They preserve disagreement. Some analysis treated the signal as consistent with an atmospheric nuclear explosion. That does not prove a test happened, but it matters because the argument was not only coming from amateurs staring at a rumor decades later. It came from people trying to understand a serious event inside a serious monitoring system. Then came the counter-reading. A White House scientific panel judged a non-nuclear explanation more likely. In that version, the signal may have come from a rare sensor problem or another physical event that imitated the optical pattern closely enough to confuse the system. That answer reduced the diplomatic danger. It did not erase the discomfort. Because both sides were reacting to the same central fact. A satellite built to watch for forbidden explosions had recorded something that looked too close to the thing it was meant to find. That is not the same as proof. But it is also not nothing. The official disagreement is what gives the case its shape. If every expert had dismissed the flash immediately, the story would have ended as a sensor glitch. If every expert had agreed it was nuclear, the story would have become a diplomatic crisis. Instead, the record holds both pressures at once. The signal was serious. The confirmation was incomplete. And the answer depended on how much doubt a government was willing to live with. The timing made the question heavier. This was 1979. The Cold War was not an abstraction. Nuclear monitoring was tied to treaties, alliances, intelligence, and the fear that a state could test a weapon while denying it had done anything at all. In that world, certainty had consequences. If the flash was declared nuclear, the next question would be who was responsible. If a responsible state was named, then governments had to decide what to do with that knowledge. If the flash was declared non-nuclear, the monitoring system itself looked less absolute than it was supposed to be. Every answer carried a cost. That is why ambiguity can survive longer than evidence. Not because everyone is lying, because sometimes the record is incomplete, the stakes are high, and every conclusion creates a new problem. The Vela incident endures because it is almost perfectly balanced. There is enough signal to take seriously, enough absence to resist certainty, enough official disagreement to keep the file open in the public mind, and enough Cold War pressure to make every explanation feel unfinished. Maybe the satellite saw a clandestine test. Maybe it saw a rare false alarm. Maybe the answer is buried in records that will never line up cleanly enough for everyone to accept. But the unsettling part is not only the flash, it is the silence after it. A machine built to remove doubt saw something over the ocean, and history still cannot agree on what the light meant.